This video will be a short explanation of factors in R. So suppose we have two judges that are rating the quality of posters at a conference, and we want to know how well their quality ratings on a scale of 1 to 5 agree with each other. So first, we'll read in the ratings table produced by the first judge, and then convert their ratings to a factor using this factor function. And then we'll do the same for the second rater. And then we'll compute the cross tabulation using the table function of the two sets of ratings. And we'll have a look at this cross tabulation later. And then we'll compute Cohen's kappa. Cohen's kappa is a measure of inter-rater agreement where a kappa of 0 means chance level agreement and a kappa of 1 means perfect agreement. So ours is about 0.73, which is pretty good. And this warning message just tells us that the upper confidence interval is exceeding 1 and Cohen's kappa can't be more than 1. So it's just being set to 1 exactly. So let's have a look at the cross tabulation and see where the judges are agreeing and disagreeing. So something's wrong here. Although there's a good correspondence between the ratings in the sense that most of the observations in this table lie along the diagonal, the rows and the columns don't actually match up. The second judge only gave quality ratings from 2 to 5, so they didn't use level 1. And the first judge only used quality ratings 1 to 4, so they didn't give any poster a 5. And every time the first judge said 2, the second judge said 3. So there's a strong correspondence there, but we can't really call it agreement because the judges just aren't saying the same thing. So why are we getting this issue, this inflated measure of agreement? To understand it, we have to know a little bit about how R handles factors. So when you create a factor in R, each level of the factor gets associated with a different integer. So to illustrate this, let's create some data where maybe instead of integer ratings 1 to 5, we have quality ratings of high, low, medium, low, right? And then let's convert these to a factor. So there are 3 levels: high, low, and medium. And each of these factors, each of these levels, it gets associated in R's memory with a different integer value. And to see these integer values, we can use the as numeric function. So we can see that factor level H for high is represented by an integer value of 1. Low is represented by an integer value of 2, and medium is represented by an integer value of 3. So this is why you don't want to use the as numeric function to directly convert factors into numbers. So just to illustrate this, suppose we have some random numbers called x, and we convert x to a factor. And now x is a factor with 5 levels, 1 for each unique numerical value. And now let's say we want to convert x back into a vector of numbers rather than a factor. So let's use the as numeric function. You can see that when we do this, what we get isn't the actual numerical values of x. Instead, what we get are the integers that are associated with each unique factor level. So we haven't recovered the actual numerical data that x represents. The way to convert from a factor to a number, rather than directly using the as numeric function, is to first convert our numerical data to character data and then convert these character data to numerical data. And now we can see we've recovered the numerical data in X. So let's try this as numeric function on our rating data and see what we get. So ratings 1 is a set of ratings where the judge only used levels 1 to 4. So when we convert these to numeric, in other words, when we look at the integer values that R associates with each factor level, we can see that there's a one-to-one correspondence between the actual numerical values of the ratings and the integer values associated with each numerical level. When we do the same thing for our second set of ratings, we can see that there's not the same correspondence. Because the second judge only used ratings of 2, 3, 4, and 5, these levels each get associated with the numbers 1 through 4, such that level 4 is associated with the integer 3, level 5 is associated with the integer 4, level 3 is associated with 2, level 2 with 1. And when we can create the cross tabulation of these two sets of ratings, they're aligned based on these integer values that are associated with each factor level. So how do we fix this? The solution is to specify, when we're creating our factor, what the levels are. So in this case, we use the optional levels argument and specify that the rating scale has levels 1 through 5, even if the judge didn't use all of those levels. They still exist. We'll do the same thing for the second judge. And then we'll recompute the cross tabulation. And now we can see that even though the second judge never used the number 1, and the first judge never used the number 5, those rows and columns still appear. And now we can see that the agreement is actually quite poor. In fact, when we compute kappa, we can see that it's negative, which means agreement worse than chance. So these raters have a lot of work ahead of them, but hopefully you've come away from this understanding a little bit more about how R handles factors internally. So thanks for watching.